Let's talk about average rate of speed and instantaneous rate of speed. So what I have is this is like example 1 from section 2.1 in the calculus book that we're using now in 2015. So I have an equation for how far something falls in a given amount of time. And that equation is right here. So the y-axis is the distance that it falls, and the x-axis is the time that it has been falling. And the equation is 16x squared. So let's kind of say I had, well, here's 0 seconds, and here's 1, and 2, and 3 seconds. So at 0 seconds, it hasn't fallen at all, and at 3 seconds, it's fallen that far right there. Whatever that y value is, that's how far it's fallen. And the first thing I want to find out is what is its average rate of speed over the 3 seconds. So you know with speed, we do distance over time. The one you might be most familiar with would be miles per hour. In this case, we would have feet per second. That is a rate of change. Speed is a rate of change. And if you look carefully at this graph right here, if I drew a line between those 2 points, I will try my best to draw a straight line. The slope of this line between that point and that point represents the change in height, and this is the change in time. In other words, it's the amount of feet per second. That is the slope of that line. So how do we calculate the slope of that line over the 3 seconds that we are concerned with in this problem? Well, let's go back to a couple of years in math, and we know that slope can be written as y2 minus y1 over x2 minus x1. Well, what are the values of our points here on this graph? Well, this one right here, my x value is 0 and my y value is 0. I haven't started dropping it yet, so I'm at the point 0, 0. And at this point here, my x value is 3. And my y value, well, I would just take the 3 and I would evaluate 16x squared with a 3. So it would be 16 times 3 squared, 16 times 9 is equal to 144. So this is the point 3, 144. So let's do our y2 minus y1. That's 144 minus 0 is 144. And x2 minus x1 is 3 minus 0. That's divided by 3. So my answer is 48 feet per second. So that's how I would find out what is the average rate of speed. The 48 feet per second is also the slope of this line. This is like so important for you to remember, that the rate of change, all it is the slope between those 2 points. So I've redrawn the graph a little bit here, and I now have marked this point right here. This is the x value, this is x sub 1, and this is x sub 2, and this point right here now is the point x sub 2, y sub 2, and this point over here is x sub 1, y sub 1. So again, we could have had our slope written as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But I want to change it around just a little bit. So we have our function. In this case, our function is 16x squared, but let's just call our function f of x. How unique, how clever. So if I have this point x sub 1 right over here, if I have the value x sub 1, this point, I could actually call it x sub 1, comma, f of x sub 1. Could not, right? Y is the same thing as f of x. But so the value of that point is evaluating my function at x sub 1. So my y value is f of x sub 1. And over here, I could have called this point x sub 2, comma, f of x sub 2. So now my slope equation would look like f of x sub 2 minus f of x sub 1 divided by, again, x sub 2 minus x sub 1. I just changed it a little bit. Well, I'm going to go a little bit further. So what I'm going to do is I am going to call the distance between x sub 1 and x sub 2, I'm going to call that distance h. So you can see it's just a number line. So what I'm going to do here is I'm going to say this is no longer x sub 1. This is just plain old ordinary x. And this is no longer x sub 2. This is plain old ordinary x plus the distance h. That's what that point is. So now I'm going to change my labels on the points. This point right here is going to be the point x, comma, f of x. And this point over here is going to be the point, again, I'm running out of space. Let's see. I think I made a little space there. This point right here is going to be the point x plus h, comma, f of x plus h. That's what that point is. So I want you to follow my progression here. This point here started out as x sub 1, y sub 1, and then I changed it to x sub 1, f of x sub 1, and now I've just changed it to x, f of x. And this point over here has gone from x sub 2, y sub 2, to x sub 2, f of x sub 2, and now since I've changed the x sub 2 to x plus h, it's x plus h, comma, f of x plus h. So now my formula for the slope becomes, sorry for it getting so crowded here, but bear with me, becomes, well, y sub 2 is now become f of x plus h, f of x plus h, minus f of x, just plain old f of x, it more look like a minus sign, divided by, well, now my x sub 2 minus x sub 1, x plus h minus x. So let's take that and simplify it just a little bit more. F of x plus h minus f of x divided by, well, that's x plus h minus x. Oh, these x's cancel out. So now my equation for the slope is f of x plus h minus f of x divided by h. This is super important, so commit it to memory. You can write it on your papers, but this is very important. If I go back to my original problem of average speed, average rate of change, I can now use this formula to calculate that. You'll see it comes out the same. Let's just do it. So if I go back to figuring out how to do this on the average rate of change over these 3 seconds right here, I can say this. Well, my x was 0, right? So my f of 0 plus 3, because 3 was my h, 1, 2, 3, plus 3, minus f of 0 divided by h which was 3. So let's work it out. I have the function was y equals 16x squared. So I have f of 3 minus f of 0 divided by 3. And what I get is I get f of 3 would be 16 times 3 squared minus 16 times 0 squared divided by 3, which is just what we expected, 144 minus 0 divided by 3. It's the same 48 feet per second that we got when we were using x2s and x1s. But what I want to find now is I want to find instantaneous. Instantaneous. I think, if I spelled it wrong, forgive me. Instantaneous rate of speed. I want to find the rate of speed right here at this exact second where x is equal to 3. That's what I want to find. I don't want to find the average rate of speed over 3 seconds. I want to find the rate of speed right there at that spot. But I got a problem, because usually when I figure out slope, I have to have 2 points to figure out slope. Average rate of speed, I had 2 points. I had that point and that point. But when I say instantaneous, I only have this 1 point. How am I going to deal with that? Well, here's what's happening. The distance h as I'm approaching this 3 seconds, well, if I went to 1 second here, I would have h of 2 seconds. If I went to here, I'd have h of 1 second. If I went to here, I'd have h of a half a second. But I want h to be exactly right at 3 seconds, so I want h to be equal 0. But that causes this terrible problem, because if h is 0, my equation, I'm dividing it by 0. And I can't divide by 0 if undefined. How do I get out of this? So I get out of this using some algebra. So my function, again, is y equals 16x squared. So my x is 3. I'm trying to find the distance, the rate of speed right at x equals 3, and my h is equal to 0 because it's instantaneous. So let's use our equation for finding the slope that we were doing a minute ago. So f of x plus h would make it 16 times 3 plus h squared. That's f of x plus h. The x is my 3, the h is the distance between the x1 and the x2. We know it's going to be 0, but bear with me to do the algebra. Minus 16 times 3 squared, all divided by h. So let's start working this out a little bit. Well, so I have, I'm going to first FOIL out this 3 plus h squared. So I have 16 times 9 plus 6h plus h squared minus, I know that the 16 times 9 is 144 because we did that earlier. And that's all divided by h. So 16 times 9 is 144. 144 plus 16 times 6 is 96. 96h plus 16h squared minus 144, all divided by h. Well, these 144s cancel out because one's positive and one's negative. And I have 96h plus 16h squared over h. So what I'm going to do is I'm going to factor out an h. So I have h times 96 plus 16h divided by h. And now, guess what? I'm going to cancel out my h's. So the formula for the slope on this equation is 96 plus 16h. Well, h is approaching 0. So this goes away, and the answer is the instantaneous rate of speed is 96 feet per second at x equals 3 seconds. Isn't that awesome?